Hi, welcome to the shortcut video on drawing Lewis dot structures of covalent molecules. We've already seen how to draw Lewis dot structures of ionic compounds. Ionic compounds are made by the transfer of electrons, usually from a metal to a nonmetal, resulting in ions, thus forming ionic bonds. In covalent molecules, electrons are shared in between nonmetal atoms. So the steps are quite different. Let's take a look at the steps. The first step is to calculate the total number of valence electrons. The second step is to draw the skeletal structure. The third step is to use the remaining valence electrons to give every atom that needs an octet an octet. And the last is to check the structure, focusing on that every atom that needs an octet has one and reduce formal charges. So here are the examples that we have. Let's look at example 1. PF3, phosphorus trifluoride. The first thing is to calculate the total number of valence electrons. Phosphorus is in group 15, so it has 5 valence electrons, and fluorine is in group 7, so it has 7. So we'll do 5 plus 3 times 7 since there are 3 fluorines, and that gives us a total of 26 valence electrons. We'll then draw the skeletal structure. To draw the skeletal structure, you have to pick the central atom. Which atom is going to go in the middle? And that's usually the one that is the least electronegative, and it's oftentimes the one that is written first, so that makes it a little easier. So phosphorus is less electronegative than fluorine. Remember, fluorine is the most electronegative element in the periodic table. So the fluorines are going to go on the terminus, and the phosphorus will go in the middle. So I draw my phosphorus in the middle and connect each fluorine to it with a single bond. Now I want to try to give every atom an octet with the remaining electrons that we have. So how many do we have remaining? We started off with 26 valence electrons, and we used up 2, 4, 6, since each single bond has 2 electrons, so we used up 2, 4, 6 electrons to make the skeletal structure. So that means I have 20 remaining. So starting at the terminal atoms, I would add pairs of electrons known as lone pairs, and we draw those as dots, around the terminal atoms to try and give them octets so that they have an octet. Remember, an octet means 8 electrons around it. So for example, this fluorine already has 1 bond, even though it's sharing it with the phosphorus. That 1 bond, we can say that those 2 electrons, for the sake of the octet, belong to the fluorine. So it already has 2 electrons. That means it needs 2, 4, 6. So I drew 6 dots around it, or 3 pairs of lone pairs. And the same thing with this fluorine. And the same thing with the other. So now all the fluorines have an octet. And in doing so, I used up 6, 12, 18 electrons of the 20 I have remaining. I have 2 more to put on the phosphorus, thus giving the phosphorus an octet. And now the structure is great. So in terms of checking the structure, I would check the structure to make sure it has an octet, and it does. All the atoms that need an octet have it. The phosphorus has 2, 4, 6, 8 electrons around it, and the fluorines, each fluorine has 2, 4, 6, 8 electrons around it. Remember, even though this electron is shared in between the phosphorus and the fluorine, when we're talking about octets, we count those electrons in that bond. We do not split them for each atom. We count them as a part of the atom. So we'll count this as 2 for the fluorine and also 2 for the phosphorus. Now we look at the second example, CH2O. So step 1, calculate the total number of valence electrons. Carbon's in group 14, it has 4 valence electrons. Hydrogen's has 1 valence electron, and oxygen's in group 16, it has 6. If you add that up together, it gives you 12 valence electrons. Next, we draw our skeletal structure. Now again, the rules are the least electronegative go in the center, and it's usually the one that's written first. Looking at this, you may think that hydrogen is less electronegative than carbon, so that should go in the center. Because remember, electronegativity increases as we go to the right. But hydrogens can never be in the center because they can only form 1 bond, since their valence shell is the first shell, can only fit 2 electrons. So with that being said, the hydrogens definitely have to go on the outside. So we're going to put carbon in the center because it's the least electronegative, ignoring the hydrogen since they have to go on the terminus. So we have carbon in our center, and then we attach all the other atoms to it with single bonds. Now when we did that, we used up 2, 4, 6 electrons of the 12 that we started off with. So we had 12 electrons, we used up 6. That means we have 6 remaining to give an octet. When drawing the 6 remaining, I started off by drawing them around the oxygen atom. I did 2, 4, 6 electrons around the oxygen atom to give it an octet in the structure, because as you can see here, this oxygen would need 6 electrons to get an octet. But in doing so, the carbon did not have an octet. It needed another pair. So what do we do in that case? We're going to shift a lone pair. These 2 dots are called lone pairs. We're going to shift those electrons to go from being a lone pair on the oxygen to being a bond between the oxygen and a carbon, an additional bond. And that forms a double bond. So whenever you have less electrons than you need to give everything an octet, like we needed technically 8 to give everything an octet, but we only had 6, that's when you're going to form multiple bonds. So I shift those electrons in between the oxygen and the carbon, and we get a double bond here. Then we check our structure to make sure everything has an octet. The oxygens have 2, 4, 6, 8. So remember, whatever bonds, whatever electrons, whether they're in bonds or lone pairs are touching that atom, we're going to count that as a part of its octet. This carbon has 2, 4, 6, 8 around it as well. Last example is phosphite. Phosphite is a polyatomic ion. Phosphorus is in group 15. It has 5 valence electrons. Oxygen is in group 16. It has 6, and there are 3 of them, so 3 times 6. And because phosphite has a -3 charge, that means that it has 3 additional electrons. So we have to add 3. So whenever you have a charge, an ion, whether it's a cation or anion, you have to consider whether you're adding or subtracting. If it's an anion, you're going to add that number of electrons. If it's a cation, you're going to subtract that number of electrons. So for anions, when you have a negative charge, you're going to add that number of electrons. So this has a total of 26 electrons. So now we can draw our skeletal structure. Phosphorus is less electronegative than oxygen, so that's going to go in the center, and we draw all the oxygens attached to that phosphorus with single bonds to make our skeletal structure. Now I look at how many I've used. In this structure, I used 2, 4, 6 electrons, and I started off with 26. So that means I have 20 remaining. So let's see how many we need to give every atom an octet. Once again, start at the terminal atoms, and I would draw 2, 4, 6, 8, 10, 12 electrons, 14, 16, 18. I need 18 electrons to give all the oxygens an octet, and then I needed 2 more, 19, 20, to give the phosphorus an octet. And that's how much I had remaining, okay? So this is my structure with the correct number of electrons to give every atom an octet. And everything has an octet, so this structure looks good. In another video, we'll talk more about formal charges and how we'll check that part, but for right now, I just want you to check to make sure every atom has an octet. So here are our Lewis dot structures for these 3 examples. Now you can go on and try your practice problems. Hope you found this video helpful. Have a quality day.